This is section 11.1, types of sequences. So we are starting a new chapter, different types of problems, different type of math. A lot of things we're going to do in chapter 11 have to deal with identifying patterns, noticing patterns, and figuring out what to do with patterns. And we'll start with the idea of a sequence. How do we determine whether a sequence is arithmetic, geometric, or neither? And how do we supply missing terms of a sequence? A sequence can be defined as a function whose domain consists of consecutive positive integers. Okay, so that's what a sequence is. It has nothing to do with the game. I just put the game up because I think it's a fun game to play. Each corresponding value is a term of the sequence. A sequence is finite if it has a limited number of terms and infinite if it doesn't. So, a finite sequence has an end, an infinite sequence does not have an end. That's basically what you need to know. And those are terms you should hopefully know outside of math as well. Some sequences have no visible pattern. For example, these are the temperatures in Milpitas over the last 10 days. Today, it was 60 degrees. 10 days ago, it was 67. But you see what happens. 67, 57, 57, 57, 55, 58, 55, 52, 57, 60. There is no visible pattern between the temperatures from one day to the next. Others have patterns. So if you take a look at this sequence, 2, 5, 8, 11, 14, and 17, what is the pattern? Well, hopefully you'll see that the difference between successive or consecutive terms is 3. So that's the pattern. This is what we call an arithmetic sequence. An arithmetic sequence, which we're going to describe in greater detail now. A sequence in which the difference between any two successive terms is constant is called an arithmetic sequence or arithmetic progression. I know this word looks like arithmetic, but when we talk in the context of a sequence, we pronounce the word arithmetic. A sequence in which the difference between any two successive terms is constant is called an arithmetic sequence. The constant difference is called the common difference and is usually denoted by the letter D. So, what you're going to find in an arithmetic sequence is that any two terms are going to be separated by D, the value of D. If they are not constant, then you do not have an arithmetic sequence. Let's take a look at example 1. Example 1. Find the common difference in the next two terms. So our sequence is 9, 7, 5, 3, and so on. When you see these three dots here called ellipses, that means the sequence keeps on going. Sometimes you will not see these ellipses, which means the sequence is finite and it stops. So, to find D, remember D is the difference, the common difference between consecutive or successive terms. Subtract a term from the term that follows it. So let's take the second term, 7, subtract the first term, 9, and your D is -2. Notice that if you take 3 minus 5, it's still -2. 5 minus 7 is still -2. You just have to take a term, subtract the previous term, and that gets your difference in an arithmetic sequence. Now to find the next two terms, add D to the last term and keep on going. So 3 plus -2 is 1. 1 plus -2 is -1. So the next two terms are 1 and -1. So the first step, find the difference. And the difference is either positive or negative. In this case, negative, because you can see the terms decreasing. To find the next two terms, just take the difference and keep on adding it to the end of the sequence or the sequence you want to know. Example 2. Find the common difference and the next two terms. 3, 4.5, 6, 7.5, and so on. So again, to find D, subtract a term from the term that follows it. Let's see if you can answer this question on your own. Alright, so take 4.5, subtract 3, or you can take 7.5, subtract 6, it doesn't matter. Your D, in this case, is 1.5. To find the next two terms, you start with the last term that you have, and just keep on adding the value of D. So, 7.5 plus 1.5 is 9, 9 plus 1.5 is 10.5. Thus, the next two terms are 9 and 10.5. So the concept behind an arithmetic sequence is not complicated. You're looking for a difference that's the same between any two terms, any two consecutive terms. A geometric sequence, a sequence in which the ratio of every pair of successive terms is constant, is called a geometric sequence or geometric progression. So, with an arithmetic sequence, we looked at the value, the difference between the two successive terms. Now we're looking at the ratio between two successive terms. The constant ratio is called the common ratio and is usually denoted by the letter R. R stands for ratio. So what you're going to see is each term multiplied by R will get you the next term, and so on and so forth. Example 3. Find the common ratio in the next two terms, 40, 20, 10, and so on. To find R, divide a term by the term immediately before it. So let's use 20 and divide it by the previous term, 40. So R is equal to 20 over 40, or 1/2. Now, to find the next two terms, multiply R to each term. So we're going to take the 10 and we're going to multiply it by R. So our next term after the 10 is 10 times 1/2, or 5. The following term after that is 5 times 1/2, or 5/2. Thus, the next two terms are 5 and 5/2. So you see how a geometric sequence works. You have a ratio that you multiply to each term to get the next term, and that ratio is going to be the same between any two consecutive terms. Example 4. Find the common ratio in the next two terms. Radical 6, 6, 6 radical 6, and so on. Go ahead and try this on your own. I know full well that some of you are sitting in class having never seen this video and don't feel like reading the book. Shame on you. You should know how to do this because you're causing everyone else to fall behind. But if you don't mind being an anchor to the rest of the class, that's fine. The rest of you, please try to do this on your own. Alright, to find R, divide a term by the term before it. So, take the second term divided by the first term. You get 6 divided by radical 6 equals radical 6. You could have also done 6 radical 6 divided by 6, and that might have made it easier to see that the ratio is radical 6. Either way, that's how you get your ratio. Now, to find the next two terms, multiply R to each term. So you take your 6 root 6, multiply it by another root 6. These two root 6's yield a 6. 6 times 6 is 36. The following term after that, 36 times radical 6, is simply 36 radical 6. So your next two terms are 36 and 36 root 6. So you see how a geometric sequence works. Each term is multiplied by a ratio to yield the next term. And that ratio is constant throughout the whole sequence. Example 5. Tell whether the sequence is arithmetic, geometric, or neither, then supply the next two terms. So we have 1/2 times 1, 1/2 times 2, 1/2 times 3, 1/2 times 4, and so on. Now, if you see this pattern, you might think, oh, it's got to be geometric. I mean, there's a 1/2 in everything. Well, not so fast. Let's see what it looks like by applying the proper steps. Let's first simplify each term. So the terms are now 1/2, 2/2, 3/2, and 4/2. Now, let's see. There's a difference, a common difference? Yes, there is. We add 1/2, we add another 1/2, we add another 1/2. Therefore, we have a common difference D of 1/2, and we have an arithmetic sequence. Now let's supply the next two terms by taking the last term we have and adding the difference to that term twice. So, 4/2 plus 1/2 is 5/2. 5/2 plus 1/2 is 6/2, or 3. So we have an arithmetic sequence. The next two terms are 5/2 and 3. Or 5 times 1/2 and 6 times 1/2, either way. So, don't look at the numbers themselves and conclude immediately without going through your proper checks. You might be fooled. Example 6. Tell whether the sequence is arithmetic, geometric, or neither. Supply the next two terms. Go ahead and take a look at this one yourself. And I know full well some of you have not watched this before today, and you are doing this in class right now while everyone else is working on the problems, and you're going to have extra homework. Well, that's fine. Just don't bring the rest of the class down with you. Alright. Now, let's see. How do we go from one term to the next? Well, you might have noticed that to get from 0.2 to 0.02, we have to multiply it by 1/10. To get from 0.02 to 0.002, another multiplication by 1/10. And guess again, multiplying by 1/10. So, you have a geometric sequence with a ratio of 1/10. Again, a geometric sequence has a common ratio between any consecutive or successive terms. Now, to find the next two terms, we're going to use R, take the last term we have, multiply that by 1/10 to get the following term, take this term, multiply it by 1/10 to get the term after that. So our next two terms are 2 times 10 to the negative 5th and 2 times 10 to the negative 6th. So you can look for patterns, look for a common difference, or look for a common ratio. Number 7, let's try this again. See if you can make a call here and supply the next two terms after you make your decision. Alright, we have log 2, log 4, log 6, log 8, all base 2. Is there a common difference? You will find out quickly that the answer is no. This is 1, this is 2, this is somewhere between 1 and 2, this is going to be 3. So there's no common difference. Is there a common ratio? Also no. If you plug these in your calculator, or even if you do these by your head, this is a 2 to 1 ratio. You multiply this one by 2. But if this were a ratio of 2, this one should be 4, and log base 2 of 6 is not 4. So there's no common ratio either. But while the sequence is neither arithmetic nor geometric, you can still figure out the next two terms by noticing that the number inside the log increases by 2 each time. So the next pattern, the pattern for the next two terms is log base 2 of 10 and log base 2 of 12, and that's your answer. So you have an arithmetic sequence with the numbers inside the log, but that doesn't make the overall sequence arithmetic because you don't have a common difference. It's not geometric because you don't have a common ratio. There will be some sequences that satisfy neither, just like we had with the Milpitas temperatures. The nth term of a sequence is usually denoted by the symbol T sub n, or Tn. In a sequence, the first term is T1, the second term is T2, and so on. The nth term represents some number down the line. It could be 1, it could be a million. If you know the formula for the nth term, you can find any term of the sequence. Now, obviously, if you have a formula, that makes it pretty easy. Beginning tomorrow, you will solve for the formula yourself. But let's today just give you the formula and see how it works. Example 8. Use the given formula for the nth term to find T1, T2, T3, and T4. Then tell us whether the sequence is arithmetic, geometric, or neither. So our formula is Tn equals 1/2 n minus 1. So let's plug in a 1 for n. That's all you have to do. So T1 is 1/2 times 1 minus 1, or negative 1/2. T2, you plug in 2 for n. 1/2 times 2 is 1. 1 minus 1 is 0. T3, you plug in 3. 3 halves minus 1 is 1/2. T4, 2 minus 1 is 1. Now, we have the first four terms. Now let's see if we can figure out if the sequence is arithmetic, geometric, or neither. Is there a common difference? Let's see. To go from here to here, we do add 1/2. To here, we add another 1/2. And to here, we add yet another 1/2. So it looks like we do have a common difference of 1/2. So we can conclude that we have an arithmetic sequence. So if you have a formula for T sub n, or Tn, plug in the different values of n. This will tell you the first term, second term, third term, or fourth term, and then see if there's a difference or a common ratio, or neither. Number 9, Tn equals n squared minus 1. Now let's give this one a shot. Go ahead and try this on your own. Plug in the proper value of n based on the term number, and then make a conclusion, make a decision on whether it's arithmetic, geometric, or neither. Alright, T1, 1 squared minus 1 is 0. T2, 2 squared minus 1 is 3. T3, 3 squared minus 1 is 8. T4, 4 squared minus 1 is 15. Those are your first four terms of the sequence. Now, is there a common difference? Well, let's see. Between T1 and T2, we had to add 3. Then we had to add 5. Then we had to add 7. Therefore, it is not an arithmetic sequence because we don't have a common difference between any two successive terms. There is a pattern, but that doesn't make it an arithmetic sequence. What about a common ratio? Let's see. To go from 0 to 3, well, you can't multiply anything by 0 to get 3, so that's undefined. To get to 8 from 3, you have to multiply by 8/3. You can see very quickly that there is no common ratio. So we have neither an arithmetic nor a geometric sequence. So just check to see if there's a common difference or a common ratio. Again, that doesn't mean there's not a pattern. The fact there's a formula tells us there is a pattern, but that pattern doesn't necessarily mean it's arithmetic or geometric. Example 10. Tn equals 2 to the n minus 1 power all over 4. Go ahead and try this one yourself and see if you get the correct answer. Alright, plug in 1 for n and you get 2 to the 0 over 4, which is 1 over 4. Plug in n as 1, 2 to the first over 4 is 2 over 4, or 1/2. Plug in 3, you get 2 squared, remember it's n minus 1, 2 squared over 4, 4 over 4 is 1, and T4 is 2 cubed, or 8 over 4, which is 2. Now, is there a common difference? Let's see. To go from T1 to T2, we have to add a fourth. To go from T2 to T3, we add a half, and you can see already there is no common difference. So we do not have an arithmetic sequence. Again, an arithmetic sequence has a common difference between two successive terms. Let's see if that's a geometric sequence by checking the ratios. To go from 1/4 to 1/2, well, we multiply it by 2. To go from 1/2 to 1, again, we have to multiply by 2. And again, to find the ratio, you take this term divided by the previous term. You take this divided by the previous term. So the next ratio is also times 2. So we do have a geometric sequence with a ratio of 2. So you should be able to identify these very quickly by the end of 11-1. This is something you're going to have to be able to do and do on your own very, very quickly. Patterns and sequences. Even if the sequence is neither arithmetic nor geometric, you can still see patterns in the differences in terms. So just because you don't call a sequence arithmetic or geometric doesn't mean you can't figure out what following terms are. Let's take a look at example 11. Find the next term in this sequence: 1, 4, 8, 13, 19, and so on. So let's check to see if it's arithmetic. And one quick look will tell you that it isn't, because the difference doesn't change. However, what you will notice is that as the numbers increase, the difference increases by 1 each time. So if you take a second level difference, you will see that the difference increases by 1 each time. Now, that does not make it an arithmetic sequence, but at least there is a pattern that you can use to figure out following terms. So even though the sequence is neither arithmetic nor geometric, we can still see a pattern. The difference increases by 1 from each term. So what the next term is, you see that to get to 13 to 19, you add 6, which means you have to add 7 to 19 to get the next term, to get 26. And if you wanted to find the following term after that, you would add 8 to get 34. So just because, again, a sequence is neither arithmetic nor geometric doesn't mean you still can't identify a pattern. Alright, how do we determine whether a sequence is arithmetic, geometric, or neither? An arithmetic sequence has a common difference. Geometric sequences have a common ratio. Otherwise, a sequence is neither. So keep that in mind. Arithmetic, difference, common difference; geometric, common ratio. How do we supply missing terms of a sequence? Well, for an arithmetic sequence, you can add d to the previous term. For a geometric sequence, you multiply r to the previous terms. Otherwise, like we did in the last example, you will find a pattern to supply missing terms. If you know the formula for the nth term of a sequence, you can find any term of the sequence from 1 to 1 billion, or 1 billion and 1. That's it for section 11-1. You will have problems to do in class on Tuesday. We will have a quiz on 11-1 to 11-3 on Friday, so that's why we're doing the videos now. If you have any questions, please ask me online, on Facebook, or in class.